All right, so who here ever programmed in Node or JavaScript? Okay, that's great. So Node. I want to start with a story. I have a love and hate relationship with JavaScript because, I mean, it's not the prettiest language in the world. I mean, it's in its way to become one of those, but it has a lot of weird behaviors that cannot change because of browser compatibility. But, well, because especially of these JavaScript weirdness, I never became very interested in Node in particular when it came around until I had to do a project to help a friend of mine with a chat server. We used a combination of Node and Socket.io, and to be sincere, I was amazed with the results. You could do the real-time thing. It was like it was awesome. And but still, frankly, the programming environment felt a little bit awkward. And I want to share you my thoughts about asynchronous programming. So, what exactly do I mean about awkward programming, especially callbacks? So in Node, callbacks are like the built-in way for you to do stuff, and because that's the built-in way. That's the native way the APIs provide you. That's what most people got started with. They basically used callbacks for everything. So Node is an extremely good programming environment for asynchronous programming, but working with callbacks and can like make learning async really hard. So let's discuss a little bit about. Oops, typo. My bad. The final slides will have this corrected. Okay, so let me zoom in here a little bit. So take this code example. It's just like it has it is a sleep function, like the one that blocks the thread. Oops. Just a second. Restart the kernel. Yes. Yes. Okay, so, all right. So I define this sleep function. And here I am using hello world, then hello, then sleep, then world. If I execute this, I do get, oops, I got hello, then world, right? But the thing here is the process is blocked because of because the sleep function actually waits for the a certain specific time frame for it to do stuff. And to show this, I've created this progress function, which simply prints dots to the screen continuously. So to see it in action, here, it did nothing because our program, our sleep function didn't allow for any other job to do anything. So, pardon, messed up a little bit with the slides, but here we have an example replacing set time. I created a timeout function because I sincerely hate the order of arguments in the set timeout function. So I replace it with a callback, and when I execute this code, you see it prints the dots, right? So it's a lot better. But okay, so okay. Here, unfortunately, not everything is going to fit on the screen. My bad. The resolution is not sublime, but here we have like a sample application in which we have two servers booting. We simulate them booting by just simply waiting for some time, and like server A boots, then server B boots, and then server A asks for a computation to server B, and then it brings the result. So result would be like this. And there you go. All right. So you see a little bit of message passing between them. And I mean, look at this. It's like really awkward to read these. If I hadn't told you, or if you didn't see it executing, you probably would have like a bad time to understand what this does. So a first approach to solve this problem is to use named functions. When you simply give names to functions, things start to have more meaning, and you don't know, you can read like server A, then check network, send request, and then a final callback. Same thing with server B. I have to execute these in order to show you guys the results in the next slide. Okay, so now finally I execute this final function. And it does the same thing. It's a little bit easier to read. I find it particularly better, but still I had to change some state up there because I couldn't figure out a better way to do it when I was writing this code for the first time. So have you heard about promises? It's like there were this new thing. Actually, it's kind of a node computer science concept. Java has something called futures, and languages that came before Java had the concept of a value that's going to be available in the future. So it was brought to the mainstream in JavaScript by this Promises A+ specification, and it allows you to instead of calling a callback, you just like yield an object that's going to be the representation of the value when it's going to be ready. So just to demonstrate it, here I have a promisified progress function, the same thing that prints the dots. It waits for the promise that the lambda returns to know when it has to finish. So here's like a demonstration of it. You have a delay, then we do something, and then we do some final thing with the result. And I'll be back. Okay, so if we take this approach to rewrite the server example, we have like a get server A constructor, then we bring something to the screen, we have then we delay for a few seconds, we check the network, then we create an object that represents the server A, and it has a function send request. And server B has just also boots up in the same manner, waits a little bit, and then creates a compute object which represents server B. Let me get this. Functions declared. With this at hand, now I have like a main function, and we can now coordinate this from a main controlling function. And if we execute this, we can like easily see, oh, so we have this promise. Oh, by the way, I'm here using Bluebird instead of the native implementation because it has like some convenient helper methods that made it easier to write this example. We have so we create server A, create server B, and then we tell server A to send request to server B. So, and there you go. So notice, this code is particularly a lot more readable. Like, there's no like server B receives a reference to server server A receives a reference to server B, and it doesn't have to worry about changing state. Like, everything is is nicely self-contained, and this was the state of the art a few years ago. Then some really smart guys noticed that we could use, we could borrow something that Microsoft brought to the mainstream, which is the concept of Async Await. They are part of ES 2018 specification, if I'm not mistaken. They were just officialized, and you can start using them after Node 8. So if we rewrite this example using Async Await, like, you can see all the function calls are become a lot shorter. So if we execute a code here, we declare the function. Now server B is also a lot shorter, like logging action, then wait for the delay, and then server up and running, and then you just return the result. We define this, then we finally also rewrite our main function, which becomes a lot shorter. So, and you can see it does the same thing. And notice this is a far more imperative way of programming. Like, you state each sequence of action, and Node just waits for you for it to finish its stuff, and then it gets back to doing the next step. So we have like a promise approach, which is a very functional approach, and we also have an Async Await approach, which more like an imperative approach. Depending on your way of programming, you might like one more than the other. So, but those are not the only ways of programming. You can actually, there are actually tons and tons of ways of doing things. In particular, something that Promises and Async Await don't solve very well at the moment is particularly when you have like a stream of events, or you await many events that will happen, that might happen, or that might even never happen. So suppose, for example, that instead of a single value, our server B returns us a stream of values for which server A must be able to await and do something interesting with that. So, following the functional approach, there's a really interesting library called RxJS. Rx stands for Reactive Extensions, which were also invented at Microsoft. There's some really smart engineers working there, and it's basically a way of you using you know, the list functions, map, reduce, filter. It's a way of doing the same thing using using asynchronous values that are happening now, that will happen in the future, and that might never stop happening. So if we were to rewrite this example using RxJS, take a look, for example, at server B. Let's start with server B, because that's where the interesting values originate. So here in server B, when it's computing, we create an observable. Interval is a constructor that generates values every 200 milliseconds, and it goes on forever. And then scan is sort of like hey, every step you just compute this sum, please. Start with value, and then each step you just increment it with the current index of the operation, and it goes on and forever. This is a lazy operation, so it doesn't do anything right now. But if we come here to the consumer, which is the send request function, it calls the compute to. It logs an action. Oh, so I just received the value here for each for each value that it receives. Then it takes only the first 10 values it receives, and then it reduces it to a single value. Then we convert it back to a promise. Here's a really nice thing. If you have your application built using promises already, you could use our XJS just to that specific part of your program that in which you have to work with many events at the same time. So, then you finish your operation with a log message. And after this, oops, I forgot to execute code here. Here again, just in case. So, here, oops, here it is, the main function. And there you go. Notice it's printing many values on the screen. So here you go. And if we compare with the previous examples, the code is a bit more complicated than in the promise example, because we now introduce a new concept, which is the observable concept. And it takes a lot of time getting familiarized with the XJS API, but it's very powerful, and look at how nicely you can read operations and compose them. I found it a blast, a joy to work with. And finally, we also could use the same approach that Go programming language uses, which is channel-based asynchronous programming. What exactly are channels? So there's this thing called CSP, communicating sequential processes, which is the concept that you have like two running threads in which they communicate with each other via a queue, and those are called channels in Go. And in JavaScript, we obviously only have one thread, but still we could use the same concept to replicate this style of programming using something called generators. Generators were actually invented to generate values in a lazy manner, and you could generate them on and forever. But these generators have a very interesting property, which allow you to interrupt execution of code and then go back to where it was at that specific point in time. So because of that, we can tell a function to wait for a specific while we do something in the background, and then do that in the front. So some really smart guy invented this a way of using, for example, you define a, oh, sorry, pardon. Here is just a helper method to convert a channel back to a promise. And we also import the CSP library. And we then look at this code. It's a lot longer. It's kind of a characteristic of imperative programs, but some might argue this is might be a little bit easier to read. Oops. Here. So we have a I based this implementation of the async example. The only part that changed was the consumption and the generation of the values, for which I used Golang channels. We have here in the compute channel, we're telling nodes. So first, create me a channel. Then you start a new thread. This is just an preemptible thread that Node can stop and resume work, but all the code here is imperative. So it replicates the style of programming of the of Go that you find in Go. So here you start with initial values, then while you are able to put values into the channel, you iterate like this. So this put method returns true whenever you can put values into the thread, and it returns false whenever the channel is closed. Once the channel is closed, it cannot be opened again. So it cannot be opened. So here we use this closing of the channel to know when we have to stop doing work. So we are doing some math with the current value, and after each step, we wait for some timeout. So we create this server B function. And here, I think the only interesting part is the computation, and for visibility, I'm just going, oops, pardon. I'll have to. Here it is. So in the consumer side, we get the channel from the compute server. We then wait for this promise to complete, which is the channel that is returned by this CSP thread. And we start with these initial values, then we listen to a value from the channel, then if we log the value, if we do some math with the value, and after we listen to 10 values, we close the channel so the producer can stop doing work. Okay? So doing this, we can finally execute our function. And you can see it also has a similar behavior to the Reactive Extensions approach. And finally, just a quick note, we also have like really interesting feature of one that is going to come to JavaScript in one of the next ES releases, which is the async generators proposal. In this proposal, we have a producer and a consumer. This is just like a really simple example, just so we can get straight to the point. In the producer, we have like a stream of values. For each value in the stream, we wait a specific amount of time, and we yield the value. This could go on forever, or you could stop anytime. And the consumer part, for await, this is like a new syntax for you to be able to await every single promise that is returned by the iterable. And with that, we log the value. So if I execute this code, it's going to give me an error message. And this is because it's not supported by Node as of today. But we have Babel adapters that does the work. I couldn't manage to work to make the Babel example work with this Jupyter notebook. By the way, I recommend it for doing presentation with the JavaScript kernel. It's really good. You can do runnable snippets of code with your presentation. Really nice. If anyone is interested, come talk to me later, then I can show you guys how to hook it up. So if I go to my terminal, which you guys can see, sorta. Okay. Nope. That's better. If you guys ever try to type to the terminal facing your back to the screen, do it. It's a fun exercise. So here we could use the Babel node executable. Babel node. Oh, there we go. To execute the async. Oops. Babel node. Here we go. Async generators example, which is the same file that I showed you guys. Oops, my bad. Okay. And there it goes. It prints the whole, all the numbers of the generator. And it's the contents of that file is the same as this one, so we go to the next slide. So, finally, the most interesting part of the talk, in my opinion, which is actor-based programming. Who here already heard about actor-based programming? Okay, cool. So, what is it? Actor-based programming was made popular by Erlang, which is the technology used by WhatsApp to power every one of our smartphones. and it's like it was created to solve problems by phone carriers. Not really carriers at the time; they didn't have cell phones, but they were landline providers. You know, the phones that you have in your home. They were landline providers, and they have like to be able to switch the streams of communication without losing connectivity. So it was created, Erlang was created by this really smart guy called, I think it was Joe Armstrong. So actor-based programming has a concept in which you have imagine actors, or you can think of them sort of like objects in object-oriented programming, with the upside that each object is completely completely isolated from each other. So you could have one. You could have two actors running in the same node thread, in two different processes in the same computer, in two completely different computers. You could have like maybe, because it all uses JavaScript, maybe have one actor running in your phone and another in the browser. So it's all possible if they all obey the same protocol. And I wasn't able to put the examples to work in the presentation in particular. So for that, we are going to go to the terminal. It's going to be worth it, I promise. So here we are back to the folder. And oops. Here we have. Here we have the same async progress function from the slide examples. It just prints dots to the screen. And here we have an actor implementation. It's just a class, right? So what's the point? You just create a class and start using classes. The difference is this guy here, down here, we use the library called comedy, because, you know, the actors do comedy, so they do drama too, which is, by the way, the name of another actor-based programming for Node. Programmers are really, really creative. So we create an actor system, and after that we get the root actor, which is the actor responsible for communicating with everyone. And we then notice all the APIs are promisified, so it's a blast to work with. And we create a child actor as a child of the root actor. And after that, we send a message to the actor. Hey, send and receive. It's going to call the method say hello. You're just message passing. And you pass the parameter world. And on the other side, you wait for for a specific amount of time. Then you return hello to a parameter from actor. And now back to the root actor. It logs the message, then destroys the system. So let's run this code and see what it does. notice we have the running progress doing work here, so it is not being blocked, and we also have received the message from the actor. Hello to world from actor. Okay, so I could do that with a simple promise. What's the point? Here it is. Okay, so what is the point of using actors? Do you guys remember the sleep function from the first presentation, from the beginning of the presentation? We're going to use it again, but oh my God, isn't it going to block the browser thread, the node thread? Yes, it's going to, but I want to show you guys something. So, if I execute this code, it's, do you see the dot here? This is all the work that the running, the progress was able to do because the sleep function blocked the thread. But I just specify the method, the mode of actor, and if I execute the same code again, it's running in parallel again. Actually, it's running in parallel, which is not a common thing for Node to do, and it happens because because of the way the actor's abstraction is defined, you could have them running everywhere. So as long as you implement a message passing protocol, you could have them running separate processes. So it's in my opinion, it's a pretty reasonable way of doing parallel programming in JavaScript. And the same way that we just passed the parameter here specifying the mode of actor, we could also specify it to run in a completely different computer. So you could possibly have an entire distributed system using just this library and running everything in Node. Maybe it's a way of porting JavaScript to the way of distributed programming, which is, by the way, I think it's going to be the next big trend in application development. So I don't know. I think it's a nice thing to pay attention to this guy. It's being developed by a company in Russia, which, by the way, the guys are really smart. They are very engaged in the project, and I don't know. It was really a pleasure to get to know this guy, and I think I'm going to use it in some of my next projects. Who knows? And back to the presentation. Okay, so. Oh, here we go. All right. So, I showed you guys the entire presentation just to share this table here. What does it say? So, it basically summarizes all the concepts that we learned here today. Depending on your style of programming, it could be functional or imperative. And depending on your need for working with single events or maybe a stream of events, one of these four cornerstones could be the best pattern that you could use to create your asynchronous programs. And actor-based programming is kind of in its own category. You could actually work, use any of these patterns with inside the actors and take advantage of Node's Node's high speed to manage many requests at the same time. It's, I don't know, it's Node is still the fastest interpreted language out there, and I think maybe Lua GAT might be faster, but it's still one of the fastest. And now we can run programs in parallel and in many different async patterns. This is the last slide of my presentation. If you guys have any questions, I'm happy to answer, or I'm not sure if we have time, but you guys can look me up later. I'm going to publish this presentation on my GitHub later, so you guys will be able to maybe reference it from there. Sorry, I couldn't do this presentation without doing lots of code to show the different approaches. It's probably best if you guys could just read it later. So that's it, and thank you very much.